Hello dear students, welcome to BYJU'S Exam Prep. So guys, this is your next session for the capsule course in which we will discuss how to measure the suspended solid which is present in a water sample. So guys, as you know that the suspended solid is a physical parameter which is very important to analyze in a water sample. As you know that guys, the concentration of this particular physical parameter should be within the permissible limit as per CPCB. So our task is to understand how we can measure it in a laboratory. At the same time, I will discuss how to measure the dissolved solid also, and I will also bifurcate how you can measure the volatile solid and the non-volatile solid. But the question is, sir, what is volatile solid? What is non-volatile solid? So I will explain each and everything in this particular session. So let's understand the complete laboratory test to measure the suspended solid and other solids also. So guys, those who are watching this video as a first time, let me tell you about myself also. My name is Krishna Sir and I'm teaching from last 9+ year, and I have done my masters from IIT Roorkee. I mentored almost 20,000 plus students for these examination, and my area of expertise is environmental engineering, RCC, structure and engineering mechanics. So first of all guys, we need to understand what is basically suspended solid, what is dissolved solid, what is colloidal solid. So guys, can I say that whatever solid you have, it can be of organic type or it can be of inorganic type. If I want to bifurcate what is organic and what is inorganic, so we can use a very simple definition. If any matter will contain the carbon or hydrocarbon, then it is an organic matter. And if that particular matter is not containing the carbon or hydrocarbon, then it is an inorganic matter, right? Now guys, the total solids which is present in a water sample can be of both the type. It may be organic, it may be inorganic also. But on the basis of size range, you can define it whether it is suspended solid, colloidal solid or dissolved solid. So as you can see here guys, if the size of particle which is lying between 10 raised to power minus 1 to 10 raised to power minus 3 mm, then it is suspended solid. And if the size of particle is in between 10 raised to power minus 3 to 10 raised to power minus 6 mm, then it is known as colloidal solid. And if the size of particle is in between 10 raised to power minus 6 to 10 raised to power minus 8 mm, then it is known as dissolved solid. So as you can see here guys, we have a very large range of the solid particles, right? So if you have 10 raised to power minus 1 to 10 raised to power minus 3, and it is suspended solid mainly, right? Now guys, our task is to measure the suspended solid in this particular session, but at the same time we will discuss how to measure the dissolved solid also. Okay, now guys, the question is how we can measure these type of solid. So let me bifurcate it in detail first. So as you know that guys, we have a size range. Let me show you this, like 10 raised to power minus 1, then we have 10 raised to power minus 3, then we have 10 raised to power minus 6, then we have 10 raised to power minus 8, right? Now you can see here guys, this particular part is known as suspended solid, this particular part is known as dissolved solid, and the middle one is colloidal solid, correct? But what happened in our laboratory, in our laboratory test, basically what we are trying to do guys, we are trying to measure the suspended solid and dissolved solid. But how it is possible without measuring the colloidal solid? How you can measure it guys? In actual condition, some of the colloidal solid is to be part of your suspended solid, but it is not truly suspended solid. Let me give you one basic definition to understand it. Let us suppose if you have a filter paper, right? If you have a filter, glass fiber filter, GFCC, glass fiber filter, right? Glass fiber filter, this is basically a glass fiber filter which have some opening size. So let us suppose if I allow the water to pass through it, then what will happen guys? Some of the solid may retain over it and some of the solid may pass through it, right? So guys, those solid which is retaining over this particular filter is known as non-filtrable solids. It is known as non-filtrable solids. And the solid which is already passed through this particular filter, then is known as filtrable solid. Then it is known as filtrable solids. Now the question is, sir, which particular part is suspended, which particular part is dissolved, and which particular part is colloidal? In actual condition, what we are trying to do, we are trying to pour the water over this particular filter, right? We are trying to pour the water over this particular filter. Now, some of the part of the some of the part of colloidal solid may retain above the filter, and some of the part may pass through it. So, we can say that, guys, the non-filtrable solid can contain the suspended solid part and the coarser colloidal solid part. And if we talk about the filtrable solids, then it contains the dissolved solid and the finer colloidal solids. So in actual condition, what happened, guys, generally we are referring this non-filtrable solid as a concentration of suspended solid in general, right? But in actual condition, you know that it is having two contain, right? One is suspended solid and another one is coarser colloidal solid part. And the filtrable solid is referred to the dissolved solid portion. Now I think you are able to understand how you can bifurcate the suspended solid and how you can bifurcate the dissolved solid also. Okay. Now guys, the question is how we can measure these type of solid in actual. So guys, basically we are trying to weigh it, right? You need to give a quantity analysis over here, guys. So first of all, you need to separate the solids and then weight it, right? So this particular method by which we are trying to measure the concentration of suspended solid and dissolved solid is known as gravimetric method, in which we are trying to separate the solids and then we are trying to measure it, and then we are trying to measure the concentration in terms of weight, right? So basically this particular analysis is a quantitative analysis. Now the question is, what is quantitative analysis? Quantitative analysis is nothing as basically this particular analysis will tell you how much amount of the solids are present. Now it doesn't matter, guys, what are the type of matter it have, or you can say that which particular chemical combination is there, right? It doesn't matter. So basically quantitative analysis is nothing as you need to understand only the how much amount of solid in terms of weight is present. That is called quantitative, not the qualitative. If it is qualitative, then it also tells us which type of quality, which type of chemical composition is there for the solids and etc. But this particular measurement or this particular analysis is a quantitative analysis. That is the beauty of this particular method. Okay. Now guys, let's understand the procedure in detail. So first we are trying to measure the total solid concentration. In the later slides, we will discuss the suspended solid part as well as the dissolved solid part. Okay. So let's understand, guys. First of all, you need to take a crucible. Okay. You need to take a crucible whose weight is equal to W. Whose weight is equal to W. And this is the crucible which is already oven dried. Okay. You need to put this particular crucible in the oven and then you have to take the weight of it. So this is oven dry weight of crucible. Let us consider capital W is this weight. Now, just a second, guys. Okay, let me hide myself so that you can see the figure properly. Now you can see here, guys, this is our water sample. You need to pour this particular water sample on the crucible. Then what will happen? The amount of water which is present over here, guys, that is basically 1 liter, and we are trying to take the 1 liter of raw water sample. So you need to put this particular raw water sample in a crucible. So ultimately we have a weight of crucible plus water in this particular case. Now you need to put this particular sample into the oven at 104 degrees centigrade. Now the question is why we are putting the temperature as 104 degrees centigrade. As you know that, guys, the boiling temperature of water is 100 degrees centigrade. So we are trying to put the temperature little bit more so that whatever quantity of water which is present in that particular sample may get evaporated and the only solid concentration will be there in the crucible part, right? That is the reason due to which we need to put the temperature little bit higher as compared to the boiling temperature. Yeah. Now guys, let's understand. If you put this particular crucible in which water is there in the oven, then all the water contained may get evaporated. Now what will happen? You may have the weight of crucible and the oven dry solid. So let us suppose this particular weight is W1. Okay, if you take the weight of this particular sample in which the solids are there, whether it is suspended solid, dissolved solid, or both of them, it doesn't matter guys, right? Whatever solid we are getting right now, that is total solid. Okay, now this is basically the total solid concentration plus weight of crucible. Okay, now let us consider this value is W1 and this value is W. Now how you can measure the concentration? It is very simple. Let's do it guys. So can I write here the concentration of total solids, the concentration of total solid can be written as how much? You know that guys, this value is W1 and this value is W. So you need to write W1 minus W. Now let us suppose this particular value which we are getting is in milligram. Okay. Now tell me guys, how much volume of water you have taken? 1 liter. So definitely this particular concentration is to be represented in terms of milligram per liter. So can I write here guys, we have 1 liter of sample. So that's why this particular value which we are getting over here is in terms of milligram per liter. Now I think you are able to understand how to measure the total solid part. Now let's understand guys how we can measure the suspended solid and the dissolved solid. So again guys, what you need to do over here, you need to take a glass fiber filter. Okay, and you need to put this particular glass fiber filter again in the oven so that it will become oven dried, and ultimately you need to take the weight of it. So let us consider the weight of oven dry glass fiber filter is W star, right? The weight of crucible was W and the weight of oven dry glass fiber filter is W star. Okay, now again guys, at the same time we will take the 1 liter of raw water sample over here. Okay, let me hide myself. Okay, so you can see here guys, this particular water you need to pour again over this particular filter. So what will happen? Certain amount of solid may retain over it, which is known as non-filtrable solid, or you can consider it as suspended solid also, as we have discussed it earlier. And some of the solid part may pass through it with the water also, right? So you need to see here guys, these are the solid which is filtrable solid which is passing through this particular filter in the downward direction. Now again, you need to put both the samples in the oven at 104 degrees centigrade. The temperature will remain same. You need to put both the sample in the oven at 104 degrees centigrade. Then what will happen guys? After oven drying it, you can see here we will get two things. One is this particular sample in which the water concentration has removed, only the solid particles are there as well as the glass fiber filter. In the second portion in which the crucible is there, and in crucible you may have the solid but the water is removed by evaporating, you can say that. Okay, now guys, can I say that this particular portion or this particular sample is the weight of suspended solid, or you can write here weight of non-filtrable solids. Weight of non-filtrable solid plus W star. So let us suppose if we add both the values, we will get W1 star. Now the second part is weight of dissolved solid, which you can write weight of filtrable solid, plus W, not W star, it is W because the weight of oven is W. Now if you add both the values, what you will get guys? W2 star. Now the question is how we can measure the suspended and how we can measure the dissolved. We need to do a simple calculation over here. Let's understand guys how we can do it. So can I write here guys the weight of non-filtrable solid, solids, or you can write here guys suspended solid also. Can I write here it should be equal to how much? This value is W1 star. Okay, we know this particular value sir, minus the weight of glass fiber filter. So can I write here guys this should be W star. So ultimately you are getting the weight of non-filtrable solid or suspended solid over here. Now if I ask you guys, what should be the concentration of it? So again, we know that already we have taken 1 liter of sample. So ultimately the concentration of non-filtrable solids or suspended solids, it should be equal to W1 star minus W star divided by 1 liter of sample. So this value is in milligram. So ultimately we can write here guys, this is milligram per liter, which is the concentration of non-filtrable solid or suspended solid. In the same method, by using the same approach, you are able to measure the concentration of dissolved solid also. So let's do it. So guys, the weight of filtrable solids, the weight of filtrable solids, or you can write here dissolved solid also. So it should be equal to how much? You can see here guys, this value is W2 star. So W2 star minus W will be the weight of dissolved solid or filtrable solid. So W2 star minus W. So this value will become weight of filtrable solid. Now guys, again you need to understand the concentration of filtrable solid or dissolved solid. It should be equal to W2 star minus W divided by 1 liter of sample. Again, so you will get the concentration of the filtrable solid and the dissolved solid. Now, I think all of you are able to understand how to measure the suspended solid, how to measure the dissolved solid. But there is one question again, guys. How I can measure the volatile solid and non-volatile solid? The question is, there is one more question I think so. What is volatile solid and what is non-volatile solid, sir? So let's understand that particular part first. Then you will understand why we are measuring it. Now what happened guys, whatever solid concentration you have in a water sample, that may be organic in nature, that may be inorganic nature. So how we can define it? Let's understand. So what is basically volatile solid? What is basically volatile solid? Volatile solids. Let us suppose guys, if you have volatile solid, then what will happen? If you put these solid at a particular temperature, like 550 to 600 degrees centigrade, then what will happen? These solid may get converted into gases, right? Then these are nothing as, these are basically volatile solid, which is not fixed. You can use a word non-fixed solids also. So these solid may get converted as a gaseous form if you increase the temperature like 550 to 600 degrees centigrade. But if we talk about the non-volatile solid, these are the solid which will not change their state. If you increase the temperature, they will remain as a solid itself. They will not change their state. So guys, let us suppose if you have 550 to 600 degrees centigrade of temperature, but still they are not changing their state. That means they are still solid over here. That means these solids are non-volatile solid. So generally guys, we are trying to refer the non-volatile solid as a inorganic matter, or inorganic fraction, and the concentration of volatile solid is to be referred as organic matter or organic fraction. Clear? Now we are using one more word for the non-volatile solid. These are fixed solid. Okay, these are fixed solid. You can use here guys one more word which is also known as fixed solid. Okay, fixed solid. Now you know that guys, we have two type of solid in our sample. Like one is non-filtrable solid or suspended solid, and the second one is dissolved solid or filtrable solid. So can I say that guys, if you have suspended solid or non-filtrable solid, let us suppose the concentration is x1 milligram per liter. Now this particular concentration will have two parts. One is volatile suspended solid and the second one is non-volatile suspended solid. Right? Non-volatile suspended solid. Or you can use a word fixed suspended solid or inorganic suspended solid also, right? Similarly, we can define the dissolved solid or filtrable solid, let us suppose x2 milligram per liter. So we can write here guys, these are volatile dissolved solid. It can be volatile dissolved solid and non-volatile dissolved solid or fixed dissolved solid, right? Now guys, we need to find these fraction. How much these fraction are there in your water sample? That is our task, right? So let's understand how we can do it. Now guys, what you need to do, you need to take the sample which is already oven dried. Now you know that guys, we have put it these sample into the oven. You know that guys, these sample we have already put it in oven. Then these sample will become oven dry sample. So we have to use these sample which is already oven dry, whose weight we already know that guys, W1 star and W2 star, correct? Now guys, let's understand how we can measure it. So what you need to do guys, you need to take this particular filter or glass fiber filter and put it into the muffle furnace at 600 degrees centigrade for 1 hour. Similarly, you need to put this particular crucible also guys, in which filtrable solids are present. So you need to put this particular sample also into the muffle furnace at the same temperature for same duration, right? Now what will happen? Those solids which are volatile in nature or they can change their state. So what will happen guys? These solid may be converted into the gaseous form. So ultimately these solid may get removed into the air. So you can see here guys, the volatile suspended solid may get converted into the gaseous form. That's why they will get removed into the air. Similarly guys, at the same time, you know that guys, we have volatile dissolved solid also or filtrable solid also. So these solid may also get removed into the air. So what is the remaining fraction which is present in the crucible and the filter, that you need to understand. So you can see here guys, you can see here in the glass fiber filter, this particular glass fiber filter will contain only one part which is known as weight of fixed suspended solid, or you can write here guys, non-volatile solid also. Weight of non-volatile suspended solid. It will be much better word, right? Plus W star. Why? Because we know that the weight of filter is W star. So let us suppose this value is W3 star. Clear? Similarly guys, if you take the weight of this particular sample which was put it into the muffle furnace, so the weight of fixed dissolved solid, or you can write here guys, non-volatile dissolved solid plus W. W is the weight of crucible and it is equal to how much? W4 star. Clear? Now the question is how we can measure the volatile part, how we can measure the non-volatile part for the suspended and the dissolved. Let's understand it. So guys, can I write here the concentration of non-volatile suspended solid is equal to how much? So you can see here guys, this value is how much? This value is W3. What is this value? This value is W3. So can I write here W3 star minus W star? So it is equal to how much? It is equal to concentration of non-volatile suspended solid, which is in milligram per liter again. Similarly guys, we need to calculate the concentration of fixed dissolved solid or non-volatile dissolved solid. So how you can write it? W4 star minus W. W4 star minus W. So this value you will get guys as a concentration of non-volatile dissolved solid. Now guys, our task is to measure the concentration of volatile suspended solid and volatile dissolved solid. Volatile suspended solid and volatile dissolved solid. So you know that guys, this particular weight is W1 star, in which two things are there: volatile suspended solid plus non-volatile suspended solid and the weight of filter also. right? So let us suppose W star. So guys, if you subtract this particular value, which is W3 star, right? W3 star will contain two things. One is weight of filter and non-volatile suspended solid. If you subtract this particular value of W1 star from this W3 star, so what you will get? The concentration of volatile suspended solid. Clear? Okay. The next one is how we can measure the volatile dissolved solid, sir. So you know that guys, this particular sample again contain volatile dissolved solid plus non-volatile dissolved solid plus weight of crucible, which is W. So guys, if you subtract this W2 star from this W4 star, ultimately what you will get? The volatile dissolved solid part. So guys, W2 star minus W4 star. So ultimately you will get the concentration of volatile dissolved solid. Now I think guys, all of you are able to understand how we can measure the suspended solid, dissolved solid, volatile solid, non-volatile solid which is present in a water sample, right? So try to do some numerical over it and you will understand in detail guys, okay? But right now we have done all the concept which is required to understand the suspended solid part. So that's it from my side guys, okay? So kindly subscribe our channel, hit the like button and hit the bell icon also so that you will get the notification regarding the future lecture. So thank you so much guys for joining the session, and we will bring some more session like this for you so that you can understand some concepts, some important concept for your GATE examination. Thank you so much guys for joining the session. Bye bye.